Good morning, everybody. This is Greg Moranci. I'm the Marketing Director at FP Complete, standing in for Michael Snoyman today. Today, we are looking for discussions of strategy, not focusing on using one DevOps tool in particular. Having said this, here's what we'll be focusing on today: continuous integration, monitoring and logging, security and privacy, and how to integrate FP Complete into your organization. Today, we have the special privilege of joining FP Complete's founder and chairman, Aaron Cantor himself, as he walks us through 3 DevOps strategies used in his company's DevOps projects that have led them to success. Aaron is a former executive of Microsoft, where he served as a program manager for distributed systems and general manager of Visual C++, the leading software development tool at that time. He architected MSN's move to internet-based server software, served as the full-time technology advisor to Bill Gates, and founded and ran the company's productivity tools team for complex software engineering projects. Before founding FP Complete, he served as CTO at web analytics firm Mentico, optimization firm Hynomics, and secure election systems firm Everyone Counts. Aaron has 18 patents in computer security and distributed systems, and now spends his time helping innovative companies adopt more advanced software technology. Finally, although you cannot talk on this webinar, please use the chat window where you may ask questions you may have throughout the webinar. Time pending, we will address as many of these questions we are able to following Aaron's presentation. Please keep in mind, you may skip all of this and contact us directly if you have a pressing question you would like to have answered immediately. Simply go to fpcomplete.com/contact us.
Hi, everybody. Thanks for coming. This is Aaron Cantor. Greetings from Southern California. Today, we'll be looking at quite a few topics at a high level. So I've tried to come up with a balanced set of material that will allow us to go fairly quickly while hitting a lot of the key strategic points in 3 of the most important aspects of DevOps. In the world we're facing today as information technology and software people, things are changing at an astonishing speed. Even compared to a decade or 2 ago, our industry keeps accelerating. And so what we really are looking for are ways to allow us to rapidly innovate with not only new features, but new features coming out more frequently, and yet with improving quality at the same time, better security, better reliability, and so on. It's a pretty high bar. And to meet that bar is hard, and we're not getting there right now in most companies. I would argue that the information technology team and the software engineering team in most companies are not really trusted by the rest of the company. I don't mean not trusted as good people. I don't mean not trusted as smart. I mean trusted as they don't meet their schedules. Either deadlines go just blow on by and sprints get longer than we expected or with less done in them. Or things come out, but they feel rushed and like they're not the quality we wanted them to have. Management starts not to trust engineering and IT, and a bad dynamic develops between those organizations where we're no longer focusing on building great things for our end users. We're focusing on struggling with problems and with friction. And I'm here today to talk about some of the solutions to this problem. To be clear, the problems we're having in engineering are not people problems. They're not lack of intention. They're not lack of brain power. It's people using old technology to do new jobs. And I use this analogy on this slide. The best craftsperson with a handsaw cannot do woodworking in the way that a robotic cutting tool can do. When we automate our work, it becomes faster and more reproducibly the same. We don't build in lots of mistakes, and that lets us focus on moving on to the next step in our lives instead of going back and reworking. When we automate with good tools, better process is programmed in and is repeated every time, and that can include things that make our systems more safe and secure. We need to understand what are the best technologies currently available and upgrade our engineering practices to include them. It's not enough to say, I'll try to work harder and be smarter. Sure, we all work hard and we all try to be smart, but the right tools are the difference. What kind of tools are we talking about? Well, it turns out that today, software engineering is no longer just about writing an app. It's about a vast cloud of automation and tools that surround the app. And I'm showing you here an actual diagram of a typical solution by FP Complete for a large pharmaceutical company, although our financial technology solutions look a lot like this too. And what you can see here is numerous components, many of which did not come from our company or from the client we were serving. The client's app lives inside that little Docker container in the upper right and isn't even shown in this architecture. This is the architecture of all of the infrastructure that surrounds an application being maintained, deployed, and operated in a scalable way in the cloud. I'm certainly not asking anyone here to go through every point in this slide. The point of showing you this, which is taken out of a project document, is to tell you there's a great deal of tooling and infrastructure available to make us more effective on our software projects. Our software should be surrounded by help and support that makes us succeed. And today, we're going to look at 4 kinds of help and support. As Greg mentioned, we'll be talking about continuous integration and deployment, which is a series of tools and practices in DevOps. For anyone who doesn't know the origin of the word DevOps, it's just developers and system operations coming together. And it's an integrated approach to how we do our engineering and the operation of our cloud systems and our server systems. So we'll be looking at that continuous integration process and the deployment of software in such a world. We'll also be looking at monitoring and logging. What are some ideas about how to tell whether our systems are actually running properly and not being broken into or falling down? We'll be looking at some ideas about how to move forward on security and privacy, which is everyone's challenge these days, and to do that without compromising our productivity. And we'll be looking at some ideas about how to take advantage of FP Complete for people who would find our experience and capabilities useful, just to augment what they're good at already in their companies. I want to reiterate, as Greg said, we welcome you to enter questions in the text chat on this webinar software. And also, if you have a more specific question that you think may go beyond in scope or detail or is more private than what would be appropriate for us to talk about on the webinar, plus which we'll only have a few more minutes at the end for questions. Longer questions, more specific questions, please go to fpcomplete.com/contact-us, and we're happy to receive longer questions and follow up with you about those too. We'll cover as much as we can this hour. Jumping right in, what is continuous integration really about? It's the notion that we should be able to integrate work from multiple software engineers frequently, whether it's every few minutes or every evening, but at a reasonably frequent speed, so that there's always an automated build that's running the software that was just written, automatically checking it for errors, and automatically producing a version of our software, if the build succeeds at least, that shows what our latest code does. That may sound like a fairly obvious idea. A lot of people are starting to do continuous integration, and a lot of others are not. If you look at a company like Amazon, Google, or Facebook, you might see software releases coming out every 5 seconds or every hour. But if you look at an older organization, you might see software releases coming out every 9 months, and a build only happening every week or every few weeks. Continuous integration aims to increase how often we put everyone's software together using automated processes and checking it for quality all the time. Traditionally, we do big merges where we tell everybody there's going to be a release at a certain date. Maybe it's the end of the sprint, maybe it's halfway through the sprint, maybe it's even several sprints on. And so releases happen infrequently, and they're a big deal when they happen. Developers feel free to move forward quickly on their code, which is great, but then there are these really painful things called merges that happen when people say, we're ready to put all of our work together. And the result is that bugs exist on developers' desktops or in small groups and teams for a long time before those bugs are merged, and you find out that you broke someone or they broke you, because the software engineering is uncoordinated. Without the information flow that comes from having a way to continuously combine our code and continuously check that combined version for errors, merges get really hard. And so what happens is people start backing down on how much testing they do. Everyone's running a separate set of tests on their desktop or on their laptop or their virtual machine. And we find bugs much, much later. And check-ins are just these great big train wrecks where all this code comes together And the result is, guess what? We do lose the trust of people outside the engineering organization because we do have longer projects and the releases come out late and often still have bugs in them. So here's some examples of why that happens. Somebody will change a component and they won't realize that somebody else was dependent on how the old version worked. Somebody doesn't realize that there was a use case that was going on somewhere else in their team. People will write manual tests that they'll run on their own machine, but that don't really represent how the rest of the system works. It just represents their own private thinking. And since testing is done separately from the teamwork, we really never know how well tested the system is. Things fall out of repair when a developer moves on from working on one component to another. Realistically, every time we make progress, we create new bugs, new integration problems, new oversights, new ways of hurting the guy down the hall. So that's clearly can't go on that way. Here are some ways to tell if you need to up your game on continuous integration, and then in a minute we'll get to how to do it. First of all, you can find people who are trying not to merge their software, thinking, I'll be embarrassed. I don't want people to see my code yet. You can see managers and project managers saying, let's revise the launch date because this non-new feature overhead work is taking a long time. And when we look at our use of expensive personnel, time, and talent, we realize they're not spending it actually building the features that our users are waiting for. They're spending it banging their heads into each other. These are signs that lack of CI, lack of continuous integration, is actually hurting your schedule and your business right now. But it gets worse because, as we know in engineering, there's also quality, which trades off against schedule. And these are some signs that you're not integrating your software properly yet, that there's room for improvement. Integration errors show up later, not only when I finally merge my code, but even when the code is running in production, and then users make weird bug reports that surprise us, and we realize that some developer made a change that didn't integrate right. Sprints don't get done on time. We can't divide our project into small periods of time that have predictable ending dates. And so that 100-meter run turns into a 400 and then a 1,000-meter run, and everybody's exhausted at the end and was never prepared to run that far. The quality of bugs, if you will, gets more severe. So the fixing of them gets more expensive. So if we're not integrating our software frequently enough, the quality of our work actually begins to suffer. We also see that there's real risk that the code won't integrate at all, meaning the build doesn't even complete. And some signs that you see really of this are a lack of communication between different people in the team. Each person saying, hey, I've done my job, so it's not really my problem if the software is not building correctly. That's a sign that engineering management and engineering process has to be more sophisticated. But as we start doing builds more frequently and putting in place tools that will help us do that, we find that our life starts to get a little bit better. Code can come out more often, even if sometimes integrating the code that somebody wrote today doesn't work too well. We often get a working build out of our system because the time that's passed between the last build and the amount of code that people have had to add to the system since then or edit since then is fairly small. So the result is we get working versions of our app or of our whole distributed system released much more often. That allows us then to be testing all the time. So we can build, and an important part of continuous integration is building a scripted, automated set of tests that will run every time the build appears to succeed. So it's one thing to say that the build tool says, I'm done building, everything looks fine. But it's another thing to say, I ran a suite of all the tests that all my engineers have written to date in an automated way, and all or most of them came back saying, yeah, I'm fine. This is a working build. By getting builds out quickly and by finding out which tests passed and failed like clockwork, we can start to understand the real state of our projects, getting feedback about how we're doing as engineers, and getting to a place where we can actually have a releasable version of the software that built and passed its tests very, very often. And I think we all realize that when we go to a large software as a service site, let me just pick on, let's say, Amazon.com for a minute. We don't go there and say, oh, wow, this year's new version of Amazon just came out with 7,500 new features. We just go to the site and sometimes there's a little bit of new software there. That's what they can do because they're using continuous integration and then continuously deploying those features. That also allows the engineering team and the IT team to get feedback from users much, much faster about whether the improvements being made are what they wanted. And it allows them to demonstrate progress and build trust between the people who are doing the tech work and the end users for whom those changes are invisible if they haven't been integrated and deployed yet. So we're going to get a continuous flow of data that tells us how is our relationship with our users working, how is our technical work working, are any new coding standards or tools that we've introduced working correctly, that new person that we hired, are they writing better code now, is the teamwork coordinated, and we can start monitoring our customer satisfaction level as a continuous thing. Instead of saying, well, they didn't like the last release, maybe they'll like the next release, we can ask every day, how do customers like today's release of the system? How do we get to this place? By using tools. The first step in continuous integration is usually actually the second line on this slide, which is to build an automated build system so that every person in the team, because they have the same software for building on their desktops and on the servers, can launch a build of the system anytime they want, meaning compile and link their latest code with all the rest of the team's latest code and all of the imported components and systems that are being used by your team's code. Building an automated build that can run in an unattended fashion and just tell you whether it succeeded or failed is mandatory for continuous integration. We then usually put that build on a server, but we know that that build is running the same software that the engineers have. How do we do that? By having a standardized image of the software that's being used to compile and build our system. Once we have that, we know that when I build the software, it's the same result, the same executable bit for bit as if you built the software on your machine or as if it were built on our team's build server. We then can move on to build an automated suite of tests, which really consists of having the engineers in the team each build some tests to see if their components are working, as well as having some quality engineers who will build integration tests, which are checking whether the app as a whole is working. And then the next step will be automated deployment to make sure that those new versions of software will be put on the server as soon as they're approved or blessed, if you will. We'll come back to continuous deployment in just a moment. By continuously integrating, we get these top-level benefits, right? We're not just talking about small technical preferences. Continuous integration changes what it's like to work in a software team for the better. It is a best practice. It makes sure we're being honest by ensuring that our software, our latest code, is really being looked at by everyone. It makes sure that nobody made a bad assumption. That means continuous integration doesn't just check if somebody typed a comma in the wrong place. It also checks, for example, did we misunderstand the user's requirement? Because the time delay between when somebody asked us to implement a new feature and when they can see that feature running, either in a test build or a deployed system, goes way down. Faster feedback loops means faster engineering and faster business improvement, which means more trust, and frankly, if you're a business, earning more money. Ultimately, we're preventing fire drills, we're preventing chaos, we're preventing friction, we're preventing wasted time, all by simply automating to speed the cycle time. No amount of great craftsmanship, no amount of when I give you the software at the end of the year, you're really going to like it, is a substitute for rapid turnaround time that the automated builds and automated testing will give us. Once we have builds coming out frequently, as I mentioned, continuous deployment is the next step. What that means is there's somebody or some bot that's going to look at the result of every automated build and decide, does this belong on the production server? Have we tested this enough? And you may go directly from your engineering team to production, or you may have a fake production system known as a staging system that your software goes to next, depending on how complex your quality is. But the key, again, is automation. And we'll look at some tools in the future, like Chef, Puppet, Ansible, SaltStack. This is a high-level presentation, so we won't be going into how each tool works, but we can use tools like that to automatically deploy the latest version of an app to a host or to a cloud. What's very important to understand in the discipline and the management of continuous integration, continuous deployment, is the notion of an IT wizard should be a thing of the past. This is an idea that we want to be done with as much as possible. We're trying to turn the production of software into a normal event, one that happens every hour or every day. That means we need to turn the deployment of software onto servers into a normal event. It's not enough to say that I have one genius who can make the server work. If that's what people are saying in your company today, let's get that person. He or she knows how to make that server work. That's a symptom that you do not yet have proper continuous integration, continuous deployment. If you feel like that and you don't know what to do, that'd be a good time to go to the fbcomplete.com/contact-us and let us know. And because we can bring you some best practices from other companies that are already there, and you won't have to reinvent the wheel. But I did want to give a couple of very specific tips about doing continuous deployment. And one is, you never want your production server to be the first time that a server has ever been in that state. So you want to make sure that you have automated tests running on a full version of your cloud system other than your production system. And to do that, there's a jargon term I want to introduce here called immutable servers. It sounds very science fiction-y, but it's a very simple concept. The idea of immutable servers is you don't mutate or modify a server that you deployed yesterday or last week. You delete it, and you make a new server that has the new software on it. Actually, you do it in the other order. First, you bring up the new server, make sure it looks healthy, and then you can take down the old server if everything looks good. In the old world, where servers were extremely expensive pieces of hardware, we would modify and modify and modify. We'd install a patch. We'd install today's build. We'd try not to take anything down. That world is largely in the past when it comes to application servers. Long-running databases that hold our enterprise database of record may be things that have to stay running for very long periods of time. But application servers, we can bring them up, take them down anytime we want. They're just virtual machines with software images on them. So if you have people in your team whose job is to be surgeons of servers, whose job is to go and modify servers to get the new build on them, that's a sign that you need improvements in continuous deployment. Because what you want to have is an automated tool that creates new cloud servers, maybe even whole new virtual private clouds, and puts your software on them, checks with automated testing that everything looks good, moves the traffic over from the old servers to the new servers, and then literally deletes the old servers because they're virtual machines. They just go away. And if that doesn't pass those tests, on the other hand, you don't delete those old servers. You just leave the traffic, you roll back your deploy, leave the traffic on the old servers, and go back to the engineering team and say, whew, our automated tests found a problem, or worst case, our users found a problem just after that latest build. So let's go back and fix it. Everything's okay. Nobody loses their job. How do you get to a world that looks like that, though? There are a lot of things that you can do to move forward with continuous integration and continuous deployment. These are some quick ideas to get you started. And of course, you're welcome to contact us and we'll help you more hands-on if you want. But you want to start by using ready-to-use continuous integration tools. And I've listed three of the most popular ones here, but there are a lot more that are easy to find too. My best tip for you is do not invent your own system for doing the gathering of code, the integration, the builds. These are complex solved problems. And when you start inventing your own tools, you're taking your good engineers, often your best engineers, frankly, because build is hard, off of building features for users. So use off-the-shelf tools, and not only that, expect that those tools won't work on day one. They have to be configured and set up and integrated with how your software is getting built. So find out how other organizations have been using these tools. I know at FP Complete, we've been doing continuous integration, continuous deployment for over 7 years, and there's a long learning curve. And one of the things that it's our pleasure to do is to work with dozens of different companies and see how everyone's engineering environment is set up, and to spread the good word, to spread useful practices between companies who are willing to share their insights. Don't try to invent continuous integration yourself. It is a solved problem. It works great. Get expertise from others. Once you've got that running, be sure to encourage your team to merge their software into the team server as frequently as possible and to write automated tests as much as possible that can become part of the ever-growing knowledge of your server about what constitutes a working build. You can see some other good tips in here, but I'm going to move on. That was a little bit about continuous integration, but we have more ground to cover. I'd like to talk to you now about a very important topic for reliability and security, which is monitoring and logging. I think most people here probably heard about the catastrophic data breach that Equifax had, in which way over 100 million people's data was compromised. But we can pick other companies. I've just listed a few here, but every week in the news, there's another problem of a company having a serious outage, a serious data breach, whether it's all the ATMs for Wells Fargo don't work one day, or whether it's, well, you get the idea. There are so many different outages, we can't even bother listing them here. But why do these things happen? Surprisingly, they often happen because no one was looking. It's as simple as that. Cloud systems are extremely complicated. They may involve tens, dozens, hundreds of machines and components and services that are all running at the same time, day after day, year after year, and yet their health is critical to the business. How is it that we have systems that are running and yet nobody is looking? Well, in some cases, it's because we don't have logging being used properly. In some cases, it's because we're not monitoring those logs. And in some cases, it's because we don't have any way to know what constitutes a trouble sign or what to do about it. So here are some things to ask about your own organization to say, is this happening to me now? Is this going to happen to me tomorrow? Am I going to be the next Equifax slide that somebody's going to talk about? First, ask yourself, do you have logs running at all? Are there files you can turn to or databases you can turn to say, what are all the events that happened or all the important events that happened in my app and in the infrastructure that runs that app, like the databases and networks and operating systems and so on? If I wanted to know, did something run out of memory recently? Was there a huge surge in traffic recently? Did something behave abnormally recently? Did some subroutine get used 500 times more than it normally gets used recently? Is that being logged? If no one is logging the things that are happening in your systems, if that's not turned on, then you know that you have a lack of awareness and you'll find out far too late. You'll be like Equifax finding out weeks after a break-in that somebody broke in, or finding out the day after your users couldn't connect to the system that you just lost a bunch of business and a bunch of customers. The problem is, how many logs do you have? How many pieces are in your distributed system? How can you possibly keep track of all of that? Well, that's where monitoring is. There's a system called log aggregation, where we bring that data together, and then log monitoring, where we have pieces of software that are simply configured to look for trouble signs in the data. People can monitor logs too, but a large distributed system may have millions of log records being made every day. May have a very large system, may have millions an hour. So we need to have an automated system for monitoring the logs of events that are happening on our servers and infrastructure, and then is sending out rapid alerts when something looks wrong, whether it looks like a system is down, whether, and this is the most common problem, the workload of some component suddenly shot up to a bizarre and unprecedented level. That's a clear sign of a bug or a configuration problem or somebody maliciously messing with your system. So there need to be systems that are running for you, looking at all of the different logs all around your distributed system, and then rapidly responding with alerts that something looks wrong. Sometimes that can even be an automated response. For example, we've done systems for clients where we'll just bring up more servers automatically if the workload gets too high. Sometimes it's a non-automated response, like we see that there is a strange bug in one of our components, and we're going to have to decide whether to roll back to yesterday's build. But without monitoring of real logs that contain real data in an automated way, honestly, we don't know what's happening in our systems. So I'm going to suggest that monitoring and logging are a natural combination. They're like peanut butter and jelly. They're good, but when you put them together, you've really got a delicious dish that you're going to want to have over and over. So are you logging enough data? Do your apps, do your developers code in your apps the generation of log events to monitor routine behavior and to monitor unusual things that have just happened? I don't mean just the app crashed. I mean, every time a user orders something on your e-commerce site, or every time an administrator logs in, or whatever your application does, every time a significant event happens, is it getting logged? If not, there's no data to learn from. And if you haven't configured your monitoring tool to look at those logs, then the data's there, but you're not learning from it. So these are a few practical tips for people who want to make progress on logging and monitoring. We want to make sure that your logs are not just going to separate files where they have to be looked at separately. You have to decide a central place, an error monitoring tool or a log aggregator that's going to look at all of your logs. And you want to have your developers create log entries, as I mentioned. Log entries also should contain lots of data. I should be able to look at them and have a sense of what's actually happening. If my component is being overloaded, who's calling me and what are they asking me to do? I think the other points we've covered, so I'm going to move on. I do want to mention our company, FP Complete, does do customization of monitoring solutions. We love that there's a lot of great core technology out there, but obviously some of the things that you've seen recommended here work best when you customize them, when you add unique log monitoring and unique log response. And we'll look at some practical tips right now for that. First of all, I want to advise anybody who wants to move forward on better log creation and log monitoring and alerting should look at open source tools. The state of the industry in commercial apps is not too bad. There are some good commercial apps for doing these things, but they're terribly expensive, to be honest with you. And we find that our clients are usually happier with open source tools for logging and monitoring. The ELK stack is a great place to start. Just be aware that most open source tools are partial solutions, that when you get them, there's a lot of configuration to be done. So the ELK stack is a great example. There's a lot to do to get it working on your system. We really like Grafana as a tool for looking at the logs and for also manual inspection of the logs. And we'd recommend that you look into those tools or have someone on your team look into them, or have us look into them for you if you prefer. That's fine too. Instruct your application developers to understand that logs are important, that somebody's going to be looking, and that if they're not creating entries that describe what the system has been doing, they're going to make life hard for operations. The whole idea of DevOps is to integrate developers and operations into a big solution that works for everybody. We do like the alerting features from ElastAlert and from Amazon Web Services. You can also find some features on other clouds. So there's a lot of tools there to be used. We're happy to help you if you don't know where to look. I also want to mention just one special tip. Good logs are so chock full of information that you want to be careful with their security, because they can start to leak information. For example, what user just logged on and what feature did they access, what product did they buy, what article did they read, things like that. So you can start to see maybe almost too much information in logs. It's good to warn your application developers not to put really private personal information in logs, but it's also, if you're really thorough, good to have somebody look at the logs from time to time and go back and tell those people, hey, scrub this stuff. It's a little too much information, if anything. That, to be honest with you, is a good problem to have compared to where most people are. Moving on now from logging to broader discussions of security and privacy, I think we all know how bad the state of the world is in security and privacy right now. Projects are getting very complicated, and I just, as a sample, want to point out this is a very typical breach. Monzo said that for 6 months, unauthorized people had access to people's secret code numbers, their PIN numbers. I'm not singling them out at all, but rather saying this is very typical. They're a bank. They're a bank, and they compromise this type of data for months and months. How does it happen? It's not only because of logging and monitoring not being in place, although that can be a big factor. It's because of complexity. Honestly, we're all trying very hard to do our jobs, but users keep asking, executives keep asking for new features, and that integration just creates point after point where problems can happen and things get overlooked. I would argue that today's applications are more about assembling building blocks than they are about just writing new code. But every time you increase that complexity by adding more building blocks, you increase the number of interface points between components, the number of places where somebody might have done something wrong. And so we're really creating a system of entry points between component A and component B. But entry points, that sounds like something I would compromise if I were a security violator, right? Furthermore, we're manually configuring our systems. People aren't using continuous deployment, and so there is some wizard who's supposed to go set up the latest server or integrate it with the database or integrate it with the web or the firewall or whatever they're supposed to do. Every manual step creates further opportunities for penetration, for defects, because people are imperfect. Even the best person in your team doing a process 100 times might do it wrong 1 or 2 times. An automated scanner is going to find that time and is going to break into your system before you know it. So we talk about DevSecOps, DevOps with security stuck right in the middle. And I think that's a good way of looking at this problem. We want to integrate all the different parts of our engineering into one pool of automation and include security and quality assurance as part of that automated process. We talked earlier about automated testing being part of our builds, but we want to go much farther than that as technical teams. We want to start from the beginning of our projects, talking about how secure they need to be. What are the risks that they're supposed to defend against or not create? We want every member of the team to understand that system downtime because somebody broke in and trashed it, or even worse, privacy violations, which you can never undo, because when people's personal information has been published, you can't unpublish it. We need to let our team members know that these are priorities and put them on the to-do list for the project. And we can't call something done if the security part isn't done. It's not something we tack on at the end. We don't build in unsecure, crazy, poorly architected apps and then at the end ask someone to build a brick wall around them. Because as soon as one little person gets through that brick wall, it's open season. So we want the engineers to know everything they do should be checked for security. That's a culture change to say that it's everyone's job. We need to integrate quality assurance with security, which means somebody is checking the software we wrote for weaknesses. Somebody is trying to break in, or at least trying to run tools that will show us common ways to break in and whether they're present. And we need to inspect our cloud systems that are running to make sure that our deployment and our system operations and administration is as secure as we meant it to be. Did somebody omit a step? We want to discover that right away and fix it. Or ideally, automate the way we set up all of our systems using, for example, an orchestration software package to automatically configure our servers so it isn't the case that late in the day, people are more likely to make a mistake, because well-written scripts do just as good a job even when they're tired. And we want to make sure that all of our systems are updated and patched and not tell people that security is a waste of time and they should get back to work on features. To do all this, we need to have a simple design. And I would encourage people to focus on the idea that simplicity and modular design are great ways to make a system easier to check for security holes. We want to make sure that credentials that are used in our modular systems, where one piece of software is logging into another service or another piece of software database, are kept in properly secure credential storage. A common form of security violations is you look at somebody's source code, oh look, there's the password for the database server right there because the app had to connect to the server. Inappropriate design. There are special credential storage services. Your team should use them. And we want to make sure that quality control remains central to our culture as developers of software, and that includes DevOps, that includes system administration. Too often, we have a good piece of software, and then it's deployed incorrectly, and that's where the problem occurs. So if you're going to test whether your code is written properly, maybe also test whether the server is configured properly from time to time. It's time well spent. So how can you move forward on security? The good news is, it may sound like a scary and intimidating area. There are lots of practical steps you can take right now, and you don't even have to take them all at the same time. You can take them incrementally. Here are some great steps, though, that I highly recommend. One is that in your engineering team, and if you have multiple teams, in each engineering team, somebody is explicitly the security person. Somebody knows that it's their job to keep an eye out for security issues and prevention, and that if there's a problem, they're the person who's going to hear about it, and they should have the power to look into anything they need to make sure that there isn't a security hole in the system. Use best practices from other companies. This is a great idea throughout all of DevOps, including DevSecOps, security ops. You don't have to reinvent anything. You can learn best practices and get a checklist together of what other companies have found helpful to look for, to find opportunities to secure your system incrementally. We just piece by piece chip away at the risks that are present in our systems. We don't have to wait until some magic day when all of security happens at once. Teach your people about security. A lot of security problems happen because one person didn't realize. Who didn't know that you're supposed to not put passwords in the source code where everyone can see them? Well, one person typed a password into the source code, but now it's there for everyone. So be sure that training in security and how important it is and how to do it is available to everyone in your team. And make sure that there's a checklist. Who took the security training? Who's not been to security training yet? Scary but true fact, you should, according to PricewaterhouseCoopers, if you want to be a normal IT operation, be spending 11 to 15% of your IT budget on security overall. That's a significant number, and I think we can all agree that with more internet work and more importing of modules and stuff, we, if anything, could be worried that that number is going to go up. So automation through DevOps is really a way to keep a lid on that number, but I wouldn't think of it as a way to make that number drive down towards zero. Security is everyone's job, and it's going to remain that way. Beyond that, I'd say use the other techniques we talked about earlier in this presentation. You don't have to be the next Equifax by having no monitoring. You don't have to allow silly mistakes by having no automation. And you don't have to create more security holes by reinventing your own tools and processes and components. Reuse is your friend. I won't spend too long on this slide, but I wanted it to be here for the people who are more hands-on or the people who are supervising hands-on engineers. These are some practical steps that you can take to start turning on pieces of security right now. Every one of these, except perhaps service-oriented architecture, is something that literally you could task somebody to do this week or next week. These are straightforward tasks. So those people who want a written version of this presentation, I don't need to talk through all these, but use the Contact Us form if you like, and we'll be happy to get you a full transcript of this material. So in short, you have a choice to turn on DevOps, to use a lot of technology that's been solved, a lot of best practices and engineering techniques that have already been solved and tested at numerous other companies, clients of ours, famous internet companies, everyone. When I say everyone, the truth is the minority of companies are already using proper DevOps, but enough companies that you don't have to be the first, you don't have to be the pioneer. DevOps is a winning formula that will get you to market faster and more reliable and with better security. Or you could be the next Equifax and the next Capital One, which is the default situation. You don't have to do it all at once, and you don't have to do it by yourself. Obviously, our firm, FP Complete, loves helping people with this stuff, and we would be pleased to be of help to you, either with service or just with information. You're not alone. You don't have to invent these solutions. On the service side, FP Complete has many engineers with years of DevOps experience. We do custom DevOps engineering projects for people. We can even do your whole DevOps system if that's what you'd like, or we can just teach your team with our DevOps Success program, which is a low-cost option that has our engineers partner up with your engineers and transfer to them as much learning and knowledge as they can in a limited amount of time at a low cost. I highly recommend that program. It's actually one of the things we're most proud of because it's a very cost-effective way to make rapid progress on problems that have been solved. Greg, who you heard, those of you who are here at the beginning, do the introduction, is also available to set up conference calls with you and with anyone who is needed from our team to help you out. And there's a link on the left side, our website, meeting/Greg234, and you can actually ask Greg to set up a call. Or you can go right to the DevOps Success Program page. We even have a phone, amazingly, which you can use. On the other hand, if you'd like more information, but you don't actually want our help, so to speak, at this time, that's great too. We're very, very happy to share what we've learned. And we're on all kinds of social media, and our blog is a fairly busy place with new good technical meat and management strategy meat coming out every month at fpcomplete.com/blog. We also have a webinar coming up for those of you who are really interested in highly secure and highly private work on the cloud, focusing on the technology called GovCloud. Which is secure and private enough for government work. And the URL is pretty long, so I've put a bit.ly short link on there, bit.ly/govcloudmigration. You can go there, and we'll have a whole webinar just on that topic. So if you're interested, especially in security and privacy in the cloud, or you're doing government-related work, or work which is as private as government-related work, you might want to attend that webinar too. We'd be pleased to have you again. Again, if you have a specific question or you'd like a more detailed look at a problem that you're facing, we're very happy to hear from you and see if we can help. That's the link. You can go there right now while we're still talking. We're going to move in a minute to Q&A, but we'll try to do more general interest Q&A on the webinar. So for more personal or private or longer issues, there is a hyphen notice, contact-us at fpcomplete.com website. And finally, I just want to thank everybody and remind you that there are lots of ways to get in touch with FP Complete, and we're always happy to hear from you and see if we can be of some assistance in your own DevOps journey. And with that, I'd like to ask Greg to look at the text chat, and he can read out a couple of questions that I will try to answer. Greg, what are we hearing from our attendees?
First of all, thank you, Aaron, for taking your time to deliver such a thorough presentation on FP Complete's DevOps Success Strategies. That was great. And a special thank you to all who attended today's webinar. Again, should you have any questions arise following this webinar, please go to fbcomplete.com/contact-us, and we are happy to assist you. I see one from Dave Schwann. Dave is asking, what is the general turnaround time for the DevOps Success Program, from nothing being done to fully automated testing, deployment, etc.?
I want to answer that in a slightly nuanced way by saying that we don't look at DevOps as all at once. And so we don't really try to say that there's a specific cutoff date. But that said, I think you can expect real progress within 3 months of starting, and I think you can expect dramatic progress within 9 months of starting. But that's very, very tunable. I think the source of those timelines is largely trying to respect all the other things that are going on in an organization. The DevOps Success Program, the reason it's so cost effective is that we're mentoring your team. And so a lot of it comes down to how much time and energy your team has to take that advice and run with it. Some people want to go that way. Other people say, look, we're too busy, but we don't have time to spare on getting these things going. Maybe we have a big growth in customers or a big security worry and we need faster progress. In those cases, we actually don't end up recommending the DevOps Success Program. We recommend going with an actual engineering consulting project. And those can be on different timelines depending on, frankly, how many people per month you want put on it. We can put on 1/10 of a person, or we can put on 5 whole people, or whatever in between suits you. In cases like that, we can have significant improvements rolled out in 2 months and really large improvements rolled out in 4 months.
Okay, that is most of the general questions. As I said, if questions arise after the webinar, please feel free to reach out to us. For those of you that are interested in the winning DevOps Success Program draw, a potential winning draw was deployed this morning. So those who have qualified for the requirements, you will be given a special email once this is selected.
Okay, I'd like to also thank everybody for coming to the webinar. I hope it was informative. I know we had a lot of ground to cover in a short amount of time. Very happy to hear from anyone who'd like more information on the topics we covered today. And I know your time is valuable, so I hope that we lived up to your expectations today. We welcome your feedback on this webinar. And with that, Greg, I think we're done, yes?
Yes, sir. Thank you very much, everybody. Have a nice day.
Thank you, everyone. Good day. Bye-bye.